Evaluate the integral below by interpreting it in terms of areas. In other words, draw a picture of the region the integral represents and find the area using geometry. At this point, we haven't really studied how to evaluate a definite integral. And in fact, this isn't a curve that we're even able to evaluate in this class. It is something that you wouldn't be able to do directly until you get to Calc 2. Now, given that, we still want to answer this question. So how do we go about answering this question? Well, the thing is, let's follow our instructions. The instructions say, draw a picture of the region. So, okay, let's buy into that. Let's see what happens. So this is a function. We'll call it y. So we have y equals, well, the square root of 2 squared, which is 4, so 4 minus x squared. And if you don't recognize what that looks like, then rearrange it some. Let's start off by squaring both sides. So if I square both sides of this equation, I get y squared equals 4 minus x squared, or x squared plus y squared equals 4. That should be recognizable as a circle. And in fact, it's a circle of radius 2, and it's only the top part, because if you'll notice, when I square this square root, it would have taken negative numbers and made them positive, and it would have taken positive numbers and made them, kept them the same. But originally, all the numbers were positive, so it's just the upper half of this circle. So there's my region. So from negative 2 to positive 2, that's the region I want. Well, let's think about this. How do we go about finding the area? Well, area of a circle is pi r squared. So pi times the square of the radius. But we're only looking at the top half of the circle, so then we would divide by 2. The radius in this case happens to be 2, because the radius is from here to here. So this would be pi times 2 squared divided by 2. One of these 2's would cancel that, and we're left with 2 pi. So that's the area of this region.